Okay, example 4.7, which is next example of the DC motor. So a 12 kilowatt 100 volts 1000 rpm DC shunt motor has armature resistance of Ra 0.2, shunt field resistance of RFW 80 ohm, and F equal to 1200 turns per pole. The machine run at 1000 rpm at no load, which is give the current 6 ampere as previous example. It's a no load current 6 ampere, and with speed of 932 rpm at full load with the current of 120 amp rated current. I think this one we get from previous example example 4.6. No load current 6 amp, the speed 1000 rpm just now, and then at speed 932 where we calculate just now, represent the current equal to 120 ampere. Determine the armature reaction effect. At full load in ampere turns of shunt frequency. This one basically you need to find the value of NF. We know already. We need to find the value of IFAR. This thing. Previously we are given in terms of flux reduction, right? In the previous example, we are noticed in terms of flux reduction drop by 5%. But this example, they ask us to find the IFAR. How much IFAR? So yeah, jadi that's meaning by that lah. Okay, so we go to this solution lah. We go direct to this. Alright. So for the 4.7a ni, basically AB we know already the point AB. A represent point at no load condition. We speed to 1000 rpm. The voltage BMF 99.4 and the current just now 0.9 ampere field current. Okay, this is point A. Point B, you know point B? Point B is point at full load, where the voltage just now we calculate 88 volt, and this represents the line between A8 and F, which represent the speed, which is equal to we calculate previously how much 800 something, I think. It's not written there here. And then point C, when we have armature reaction, when the IF drop by this amount, we don't know yet. We have to calculate this amount, delta IF. Okay, so point C just now we know that the speed when armature reaction take place equal to 932 rpm. Okay, this is point C, right? And we know based on previous discussion, IF effective where here equal to IF minus IF armature reaction. This formula you need to know lah. I effective mean this current at point C. Point B ni IF, a real one, the actual one, and this is a drop of flux given by IFAR. Now we're going to find what is IFAR. Okay. Now in order to find point C there, then in order to find point D, then you can have the relationship between C and D, C and D, because you need to find the voltage, because the data is given based on this line, 1000 rpm line, which is point D. Okay, so based when we know the voltage, you can find the current, right? Just like that lah. Because the plot give us relationship between AA and IF. But the challenge now we need to know what is AA at point D. Okay, so you can use this relationship. What is relationship? C dengan D ni. So AA point D kat sini equal to AA point C, which is full load, equal to speed at D divided by speed at C. Understand? Speed at C. This relationship that we know just previously. AA no load we don't know yet lah. AA no load at point D we don't know yet. You're going to find this. AA full load C we know previously 88 volt equal to speed no load we know already 1000 rpm, and the speed at C we calculate already previously, which is 932 rpm, right? I think based on previous example lah, we have calculated already the 932. You can see here how much the speed during Ni. This one. 932. This speed happened at armature reaction just now. So we use this speed. Okay, we use this speed. I hope you can follow me. So then you can find the point D, voltage at point D, which is divide lah. No load 1000 divided by full load speed. How much at point C? 932. 932. This is speed with armature reaction. C is point at armature reaction, which is 932. Okay, multiply by the voltage at full load, which is 88. Then we got the no load voltage, which is 94.4, 94.42, which is point D lah. Point D, because the data we got from the point D. Okay, and then you look data at point D ni, how much the current at the point D. So this point D equivalent to this current lah, which is I effective, which is equal to, based on the graph, they give us, give us the current about 0.86 ampere. This is equivalent to IF effective. Because D is point effective current, still dengan the same point lah. But the data you need to find from point D, the data for voltage. When we know the voltage, we can find the current. The current equivalent to I effective, 0.86. Then you use this formula just now. I effective 0.86 equal to IF minus IF armature reaction. IF we know 0.99. This one is 0.86. Then you can find the IF AR, which is equal to 0.13. This is a drop of current. How much? 0.13 ampere. Then to answer the question, just multiply lah. The question asks us to multiply IFAR with NF. NF 1200. IFAR 0.13. Then we got the answer 156 ampere turn per. That one solve the first problem. Determine the armature reaction. First one. Okay. Fine. Okay, number B. Number B ni, this how many series? This is a compound machine. One of friend just now send the chat ask about the cumulative winding. The cumulative winding, we know that it can be add the flood or it can be reduce the flood. When you add the flood in the machine, we call it cumulative compound. When you reduce the flood, total flood in the machine, they call it the differential compound. Okay, basically cumulative compound ni, what happen, you want to maintain voltage at no load and full load. You want to maintain voltage. That means you want to get the zero speed regulation. Normally, you know, right? At full load, the voltage drop. Just now I show you, right? From what value just now? You remember here, okay? No load, you got 99.4, right? Now the full load, you got 88, right? This the drop of voltage. So in order to increase the voltage, higher voltage, same as no load, then what you got to do? You need to inject more flux. More flux. More flux mean that the bigger the flux, you mean that you need a cumulative compound machine lah. The cumulative compound will generate more flux, more resultant flux in the machine. So that basically, by using that, the full load voltage equal to no load voltage. Or you can say that this method basically to improve the voltage. Voltage at full load very close with the no load or similar voltage lah. That is meaning by cumulative. When we talk the differential compound, normally differential compound ni you want to make the zero speed regulation. Okay, we know that when armature reaction take place, the flood drop, right? The flood drop. So in order the flood drop, the speed increase. The speed will increase. So differential compound, basically you want to maintain the speed, such that the speed can be maintained at full load conditions. Something. So that's two different things. So we go to first case, B, point B. So how many series field turn per pole should be added? NSR, this NSR should be added to make this machine into a cumulative compound motor. Short, they ask here, use short shunt only. Oh, the speed will be 800 RPM at full load. So they want 800 RPM at full load. Okay. So neglect resistant of series field winding. So we can say that n RSR equal to 0 lah. So what happened now? See this number B. This one number one done already. We go to number B. Okay. Okay, this is the pattern for number B. Number B ni you can see the A, B, C you know already. A point A we know already. B we know already. C we know already. C is point with armature reaction. Now we have to go from point B to point D. Point D ni represent the curve of armature reaction, other armature reaction plus cumulative compound. The speed here will be 800 RPM. They ask it that. They want to maintain the speed under RPM. Under RPM. Okay. Previously, in point C, the speed increased, right? Increase 293 something, right? Now you want to make the speed similar lah like previous condition. So this happen now. We can see exactly here lah. So this B A give IF, C IF. Previous IF lah. IF with armature reaction. C is point when current drop due to the armature reaction IFAR. And point D is a new effective current due to the cumulative winding. So the point D now is become IF effective. Dia lain sikit tadi. Sebab because of cumulative compound, the flux change, increase from C or from B to D. That D represent a higher field current. So what is point D basically? Point D basically equal to this equation lah. You want to find point D. Point D basically is equal to I effective. I effective equal to this turn ratio plus or minus this one. I effective. I effective equal to IF minus I effective armature reaction plus this NSR over NF IF plus IE that we studied before. And when we have cumulative winding, we have this condition for the effective current. If cumulative, you use plus there lah. Okay, sebab you increase the flux. But if differential, you put minus there. Okay, so this current basically IF plus this. So this one represent this amount of current. Can you get me? So IF minus effective plus this one that give the effective current here. Formula, you need to know this formula basically. And then we go to the point, each point there. So what is the equation between this point? A, B, C, D, E. What E? E is the data that we're going to obtain. So once we know E, we can find the I effective. Because all data based on point 1000 RPM speed kan. The data given us based on speed the curve of 1000 RPM. That means we need to find data point E. So D can be represented by point E. So now we can see that thing here. So D and E. So E, no look E, we don't know yet. E, no look E, we don't know yet. Over E full load D, we know, or D 88 volt, equal to, we no look E, speed at no look point equal to 1000 RPM, divided by the speed of point D, which we given us. This one given to us lah in this question. How much? 800 RPM. They ask us to set the speed equal to 100 RPM. So you need to check the speed of how much they give us lah. It's not just you need to check the question first lah. They say the speed equal to 100 m. When we put the cumulative winding at full load, the speed equal to 100 RPM. Alright, so we know the data already. We know the point D voltage, we know the point E speed, we know the speed at point D. So after that, we can calculate voltage at point E based on the ratio. That how much? 1:110. 1:110. The answer for this E here is to 1:110, which is higher than no load voltage lah. No load is just 99 kan. You can see the graph here is 1:110, higher than EA no load. Okay. And then after you check the graph, between AA and IF. So this one gives us the current 132, which is effective current. I effective here is 132. Okay, and then use this formula to solve the things. Here better. Okay. Okay, then you know this formula. So I effective equal to 132 here equal to IF plus this equation. IF minus IF first. Atau you plus this one first minus IF later on. Alright. Okay, so 1.32 equal to 0.99 and SR you don't know yet. You have to find this one. And F1 we know 1200. IA 120. IF 0.9. I effective. We get this one previously. From previous from previous answer part A lah 0.13. Then we can find the number of turn required in the series winding. Tu. Boleh. Jadi that's how you solve problem lah. So in your exam later on they will give the speed, particular speed lah. Or maybe they switch either one lah. They can do, we can manipulate a little bit to make sure you really understand this. Okay. This point soalan B lah. Boleh. Cumulative mean we increase flux. Flux increase from point B to point D at full load. Why the same line? Because full load. Voltage similar. B without armature reaction. Full load. C with armature reaction. And D is a with armature reaction plus the cumulative winding. That's thing. So that more, if you see this plot, you can see more insight lah what really happened in the motor. With without armature reaction, where is the effective current and so on. Where is the armature drop here? You know, this is a drop of field current. This is an increase of flux given by this formula, and so on. Okay, that gives us the number B. Okay, number C I will do next lecture, and now what I'm going to do, I will talk about a little bit on the about your quiz, third quiz. I'm not very 1 minute. Yeah, this quiz. Okay, this one. I want to express here because I found maybe 20% of you answer wrongly. Okay. Remember this structure, they can come back. We will ask again in your test 1 or your final exam. It can be test again. Don't take it easy. You must be careful about the thing. Okay. Basically, when they ask you to find inductance, right? Inductance, then when number B, letter where they ask you to use force, so use the formula inductance to find force. Don't use the formula differential of energy. That not solve the problem. Why we ask you to find the inductance? Because we ask you to use the formula of inductance to find force. Okay, some of you okay lah, they answer correctly, but I think about 20% of you they still use the differentiation of omega F over dx to find the force. It's not correct lah, because you don't know, they didn't ask you to find energy here. They ask you to find the inductance only. So just use directly formula for inductance to find force. That's why I'm very not very happy with some of you. Because you give you correct direction already. Find inductance. So after that find force. That means you have to use force equal to half I squared differentiate of inductance. DLX or DLG over DG. That is the correct answer. That's one thing. So we do same thing maybe later on, but we change the label there maybe. Is it 1 minute? Solution. This one. Yeah, this one. Okay, this okay. First you draw this one. I found many of you okay correct this to do. And they say okay because you got two two part and to a gap there. So we know that we got S1, S2 lah. That most of you okay, understand that one, okay, fine, no problem. Okay, so what is S1? G1 over mu naught A1. A1. A is a cross section of A1 equal to 2Q squared. Okay, and S2 you have same air gap length, so G divided mu naught A2. A2 3Q1. Okay, and when you going to find total resistance or total R equivalent there or equal to S1 plus S2, and you can do this one lah. You can do like G over mu naught 1 over A1. And can you get the answer for that? So this is the answer for the G over mu naught 5 over 6 1 over Q squared. But some of you I found they just add this to, they just add A1 plus A2 directly. You understand that become 5Q squared. Whereas this different way to do that. You cannot just add the cross section here by A1 plus A2. Some of you got, they make like that lah. They make like something like that. Okay, you can see this one. Okay, dia buat macam ni, direct je. A equal to, so don't repeat this same mistake. Otherwise you lost, you fail your exam, your first test one. Dia make A1 plus A2 equal to 5Q1 directly. Which is not correct. You must do one by one like that. You must A1 plus A2, then you have to do like that. This is the correct answer for you. Not just if you put like that only, then you got the wrong answer already lah. G over mu naught A, you make it like that. Okay, this for the L R. So L become N squared over N squared over R, right? So become N squared over forgot mu naught G mu naught 5 squared like that. So it's wrong lah. It's supposed to be here. Now you got 5 squared because you directly use A only. You should do properly like this one. So don't repeat the mistake lah. Don't just add A equal to A1 plus A2. It's not correct. It's wrong. Okay. Luckily it's quiz. Your test, then you lost a lot of mark already. Maybe you lost half mark already. Maybe you fail out the test. Okay. So don't repeat the same mistake like this. You cannot just cross section A equal to A1 plus A2. No, you have to do properly like that. One by one. Okay. So don't repeat the mistake lah. This is what first thing I want to mention here. Okay, this is your S, this is your R total, then you got L lah. L total equal to N squared over R equivalent lah. You got this answer. Okay, then because we know inductance, so directly use this formula torque to find the torque. Use half I squared dL over dg. This one because we use dg. The original formula is half I squared dlx, right? Our dx. That's why you got plus. But because we have g component there, if you got g, not x, then we know that dx equal to minus dg. Then this one become minus lah. Minus there. Minus half I squared dlg over dg. Then you solve the problem, you got plus there, not minus. If you got minus, I minus half mark only lah, 0.5 mark. I deduct. You got wrong sign there. The answer should be plus. Okay, so I just want to remind you again, be careful about this structure and how you calculate the area. Don't just add A1 plus A2 like that. It's wrong. Okay, it's not like that. It's not like simple like that. You need to do properly. A1, A2 like that, and then solve the problem properly. Then you can get the answer. Ada soalan?